Question 2 of midterm 2 asked to find the quadratic approximation of essentially the binomial expansion of square root of 1 plus epsilon. So we know that to the linear approximation, the first term, this is just given by 1 plus epsilon naught over 2. We use this expansion, the simplification, quite a few times in E and M. So it's an important approximation that we want to kind of know and understand. And this is just the linear approximation, and we want to find the quadratic approximation. So the quadratic one would be the term that includes the epsilon naught squared term. So we can do this essentially by seeing that this is just a Taylor series expansion, or more specifically, it's actually a Maclaurin series expansion. So right away we can see that our function is of epsilon, and it's simply given by the square root of 1 plus epsilon. Now, the reason that it's Maclaurin is because we are expanding this about some point, and the expansion of the point, the expansion point that we're expanding this expression around is just 0. So if we recall, the Taylor series expansion has the general formula f of x is approximately given by the sum from n is equal to 0 of infinity of the nth derivative of our function evaluated at some position a, x minus a to the power of n over n factorial. So this is the general expression for a Taylor series expansion, and it becomes Maclaurin when we are evaluating around our point a is equal to 0. So in that case, we have our function f of x is approximately the sum of n is equal to 0 to infinity of f to the power of n evaluated at 0, x to the n over n factorial. So what this term here means, it's the nth derivative of our function evaluated at 0. In this case, our function f of x is our f of epsilon. So we'll start with f of epsilon is equal to the square root of 1 plus epsilon. And what I do in these expansion problems, or these series expansion problems, I always simply write out the derivatives first. So we always want to know kind of what is the sum of the derivatives evaluated at some point multiplied by the function, no, sorry, not the function, the variable to the power n. So if we start simply with just the derivatives, then we can evaluate them all, and then it's just plugging into the sum. So the first derivative of our function with respect to epsilon is simply 1 over 2, 1 plus epsilon to the negative 1/2. That's the derivative of this expression here. And the second derivative would just be the derivative of this term, which is just negative 1 over 4, 1 plus epsilon to the negative 3 over 2. Now again, we're always evaluating this derivative, these functions, at some specific point. In this case, we're going to be expanding around the point epsilon is equal to 0. So in that case, we essentially evaluate these at epsilon is equal to 0. And all of these will just be 0. Which means that we're going to end up with having our sum of f of epsilon is approximately, now we can plug in the first two or three terms of our expansion. So we have f 0 evaluated at 0, x to the 0 over 0 factorial, plus f to the 1, which is the first derivative, evaluated at 0 over 1 factorial, x to the 1, and I'll squeeze this last term in here, f of 0 squared, x squared over 2 factorial. So this is the general expansion that we're looking for, and the reason we go, sorry, I have put x here, this should all be epsilons. Just correct that quickly. And again, it's epsilon in this case and not x, because epsilon is our variable of our function that we're expanding. So these are the first three terms of the sum of the Taylor series expansion. And we're only going up to the first three terms because we're looking for the quadratic term of epsilon, which is what we end up with in this term here. So we can stop the expansion after that quadratic term. So now we simply have to plug in all the values that we already know. So the 0th derivative of our function is just the function itself, evaluated at epsilon naught is equal to 0, so that's just 1. And then epsilon to the power of 0 is 1, 0 factorial is 1. So we end up with just 1. Now we take our first derivative of our function evaluated at 0, so we have 1/2, then 1 plus epsilon to the negative 1/2, which is just 1/2, because of course 1 plus epsilon, when epsilon is 0, is just 1, multiplied by epsilon over 1 factorial, which is just 1. And finally, we have our last term, which is now our second order derivative of our function evaluated at 0, which is just this term here with epsilon is equal to 0, which gives us a -1 over 4, multiplied by epsilon squared over 2 factorial, which is just 2. So finally, we end up with our expansion of f of epsilon is approximately, not equal, it's approximately, 1 plus epsilon naught over 2 minus epsilon squared over 8. So again, this question was just looking for the quadratic approximation, quadratic expansion of our function 1 plus epsilon square rooted. We know right away that that's our function, so that's f of epsilon, and this is a Taylor series expansion, or again, more specifically, it's a Maclaurin series expansion, because we're expanding around some point a is equal to 0. In this case, our point is epsilon is equal to 0 that we're expanding around. This simplifies the Taylor series expansion formula, so that we have this. The function is approximately the sum from n is equal to 0 to infinity of our function to the nth derivative evaluated at our point a is equal to 0 times the variable to the n over n factorial. Again, when I look at these problems, I essentially write out all the derivatives first and do all my evaluations. So we have our function, and then we take the first derivative, and we have the second derivative, and this kind of gives me a nice clear understanding and a clear kind of progression of how that derivative changes and what each of these values is. We could even write in what this is equal to. So this is just 1, 1/2, -1/4. And that allows us to then, when we go and expand into our sum, simply we just plug and substitute in the values that we already know. And again, we want to go up to the quadratic approximation, so the quadratic term of epsilon, which comes in when we have epsilon squared. Plug all of our values in of our function to the whatever derivative, so in this case the first derivative, second derivative evaluated at some value of epsilon, which is just 0, Maclaurin series expansion, and that expansion gives us an approximation of our function f of epsilon to the quadratic term, which is just 1 plus epsilon over 2 minus epsilon squared over 8.